Hello everyone, this is Devi Priya from 3rd Sem BCA. Now I am going to explain about deadlock. Definition of a deadlock in operating system. Deadlock is a situation where a set of a process are blocked because each process is holding a resource and waiting for another resource acquired by some other process. Consider an example. When two trains are coming towards each other on the same tracks and there is only one track, none of the train can move once they are in front of each other. A similar situation occurs in OS when there are two or more processes that hold some resources and wait for a resource held by other resources. In this, we can see that resources 1 is assigned to process 1, process 1 is waiting for resources 2, and process 2 is waiting for resources 1. There are 4 necessary conditions for deadlocks. First one is mutual exclusion, hold and wait, no preemption, and circular wait. Mutual exclusion. Mutual exclusion is nothing but a resource can only be shared mutually in mutual exclusive manner. It implies if two processes cannot use the same resource at the time. Next is hold and wait. A process waits for some resources while holding another resources at the same time is known as hold and wait. No preemption. The process which one scheduled will be executed till the completion. No other process can be scheduled by the scheduler meanwhile. Last is circular wait. All the processes must be waiting for resources in a cyclic manner, so that the last process is waiting for the resources which is being held by the first process. Now let us study about deadlock handling techniques. There are 5 different deadlock handling methods, and with using them deadlock problems can be avoided in operating system. First is deadlock prevention. It is very necessary to prevent deadlock in operating system before it can happen. So system immediately identify every transaction before getting its execution and ensures it does not get to deadlock problem. If that time any transaction may occur deadlock issues, then it can get to execute its instruction. By making sure that one of these necessary conditions does not hold well, occurrence of a deadlock can be prevented. First is mutual exclusion, hold and wait. Mutual exclusion is not required for shareable resources, must hold for non-shareable resources. For example, a printer cannot be simultaneously shared by several processes. Hold and wait. Hold and wait must guarantee that whenever a process requires a resources, it does not hold any other resources. Third is no preemption. If a process that is holding some resources requests another resources that cannot be immediately allocated to it, then all resources currently being held are released. Preempted resources are added to the list of resources for which the process is waiting. Process will be restarted only when it can regain its old resources as well as the new ones that it is requesting. Fourth one is circular wait. Circular wait imposes a total ordering of all resources types and require that each process requires resources in an increasing order of enumeration list. Now let us study about deadlock avoidance. That is how to avoid deadlock. In deadlock avoidance, the request for any resources will be guaranteed if the resulting state of the system does not cause deadlock in the system. The state of the system will continuously be checked for safe and unsafe states. In order to avoid deadlock, the process must tell OS the maximum number of resources a process can request to complete its execution. The simplest and most useful approach states that a process should declare the maximum number of resources of each type if whenever needed. The deadlock avoidance algorithm examines the resources allocation so that they can never be a circular wait condition. There are two steps in deadlock avoidance: safe and unsafe states. Now let us study about what is safe state and unsafe state in deadlock avoidance. A state is a safe if the system can allocate resources to each process, that is up to its maximum requirement in some order, and still avoid a deadlock. Formally, a system is in a safe state only if there exists a safe sequence. So a safe state is not a deadlocked state, and conversely a deadlocked state is an unsafe state. In an unsafe state, a operating system cannot prevent processes from requesting resources in such a way that any deadlock occurs. It is not necessary that all unsafe states are deadlocks. An unsafe state may lead to a deadlock.